Well, I hope you're ready for your head to explode because I'm finally going to get to that thing that I've mentioned a couple of times, which is we have to deal with the case of moving observers. So I've color-coded this. First off, in blue is what's going on at some time t. And in green is what's going on a little later at t plus delta t. Okay? What's going on at t? At t, you're the observer. I'm going to just say you're the observer, you're at rest, you're watching something up here. Let's say this is a plane, okay? So here in blue is what you say the position of the plane is at time t. Here is a whole nother observer. Notice I've drawn a train track here. This observer is on a train and the train is going this way. Okay, and I've called this observer, you see that little script T in there? That observer is observer T. Your observer O, that observer is observer T. So one more blue vector, because it happened at time t that I've drawn, is where the observer t was according to you at time t. And then one more blue vector. This blue vector here is where the plane was according to observer t. All right. Now let's look at what happens a little bit later at t plus delta t. That's what I've got in green. At t plus delta t, you're still here. The plane has moved to here. So now this long green arrow here, that represents where you say the plane is at t plus delta t. Of course, the person on the train, because the train's moving that way, has moved some according to you. According to you, their position vector is now this green vector here. According to the person on the train, the plane is now here. You see this third green vector? That shows where this person at time t plus delta t says the plane is at time t plus delta t. Okay, now we have to figure out what you say the velocity is and what the person on the train says the velocity is. So you say, assuming this is all constant velocity type of problem, no acceleration, you say that the velocity is the green r at t plus delta t minus r at t over delta t. That's what you say the velocity is. And r at t plus delta t minus r at t, that's this displacement vector right here that I've drawn in black. Okay? Now, meanwhile, you also have an opinion, as observer O, about the train's velocity, okay? So I could call that r sub train at t plus delta t minus r sub train at t divided by delta t. That's this vector right here. That's the difference. And if I divide by delta t, I get the velocity. Okay, so that's, according to you, this is the velocity of the plane. And according to you, this is the velocity of the train. Now, the question is, what does the person on the train say the velocity of the plane is? Okay, so I will call that v sub plane from the train. Now, v subplane from the train. This is so crazy tricky, I had to label everything. V subplane from the train is, this is the vector d, that's where the plane appears to be from the train at the later time. And this is the vector c, where the plane appeared to be from the train at the earlier time. And the velocity of the plane from the train is just d minus c over delta t. Now, look at this crazy shaped quadrilateral here. You can see that c plus b is a plus d. So c plus b is a plus d. C plus b, going that side away around the quadrilateral, is a plus d. So if I want d minus c over delta t, that's the same thing as just subtract c off of both sides of this equation and then subtract a off of both sides of the equation, and I get that d minus c is b minus a. So d minus c over delta t is b minus a over delta t. But b over delta t, that's that displacement divided by delta t. That's the speed of the plane. And minus a over delta t, you see that's the a, and that's the delta t, and that time delta t is how long it took the train to move that far. That's the speed of the train. So, more accurately, the velocity of the train. So we've just learned this. That the velocity of the plane as viewed from the train is the velocity of the plane as viewed by the observer minus the velocity of the train as viewed by the observer. Okay, that is the central result of section 4.3, is basically how velocities add or subtract depending on who the observer is and how much they're observing. Definitely look at examples 4.7 and 4.8 now. 4.7 is what happens when the plane doesn't try to correct for the crosswind, and 4.8 is a problem about how the plane would have to fly if it needed to correct for the crosswind. So those are on, all this is on 90 to 92.